All right, so starting for our last lesson here, we're going to start with logarithmic functions and their graphs. So we're going to talk about common logs, natural logs, of trying to find these with or without calculators. And then there's going to be this conversion between exponential functions and logarithms, and then logarithms to exponential functions, change of base, and then graphing. Oop, there you go. So I said this before, but your logarithmic functions are going to be an inverse of your exponential functions, which is why we talked about inverses then exponential functions. So we can talk about this. So if we have an exponential function that is y equals a to the x, what we have is the inverse function. Remember, that's just changing that x and that y. So your inverse function of this is going to be x equals a to the y. So the way that we represent this function is that, like I said, in the end, what we're trying to find is that y. So we're trying to explain how we find that y. And what it is, it's going to be the log base a of x. So what the y is it has to be the power on a, whatever a is, to get x. So as an extension of this, we defined our logarithmic functions are going to look like this. Y equals, so it's log, that's base a of x. The second, let me write that again. So I got tangled when I was trying to write that. The base is a. Means that we're looking for a number y such that when we put that y as a power of a, I get that x back. And what we're going to have here is that x is always going to be positive, and a is going to be a positive constant other than 1. So this is going to come from the fact that the only way we're going to have this working for us, as we had said it when we have an exponential functions, our y's are going to be positive, meaning that our exponents would be positive. So the only thing that's going to happen if we have positive exponents is x would have to be positive itself. So we read that this log ax as logarithm base a of x. So if I was talking about log base 2 of 8, remember what I'm looking for is I'm trying to take that 2 and I'm trying to figure out a power that I put on 2 to get 8. So in this case, it would just be 3. So that is how your logarithms are working, is we're just finding that power we put on the base to get that x. So just as a note, the log of base a, if 0 is always going, or sorry, of 1 is always going to be 0, because I have to figure out, well, what power do I put on a such that I get 1? Well, the only thing that's going to work is 0. And then log base a of a is going to be 1. So once again, what power do I put on a that I get a back? Well, my only choice there is 1. And this we're going to use a fair amount. So remember, like I had said before, that log base a of x equals y can be rewritten as x is going to be a to the power of y. So logarithms are exponents. So just representing a inverse to inverse to an exponential function. So we're going to convert the following logarithm as exponent as a logarithm. Oops, sorry, my tool wasn't writing. There we go. So we had said if we had log base a of x equals y, that is the same as saying as that we have a to the y equals x. So we're going to take these exponentials and rewrite them as logarithms. So what we see here is that my base is going to be the 4. So I'm going to do a log base 4. So if you notice here, this y becomes the exponent. So those go there. So we're going to take that exponent of 3, and that is what this should equal to. And then when we raise a to that exponent, we get this x. X is what goes inside the logarithm. The same thing here. I have a log, but my base is x this time. I have to do the log of 243, and what should pop out as result of my logarithm as that exponent. And then there's my solutions. Here we're going to convert logarithms to exponentials. So let me write out that conversion again. So we know log of a of x equals y is equivalent to saying that if I have a to y, I get x back. So here we're just converting. So this a here is my base, becomes the base of my exponential. So we're going to keep that 3. Then this here, this y is my power. So we have power of 4. And then that x goes here. So 3 to the power 4 should be equal to 81. Once again, if we look at this one, we got 6. The exponent on it has to be this x. And what it should equal is 216. All right. So worksheet 1 and 2 is the same thing. Just got a couple varieties of these, but just convert these into logarithmic equations, and then convert these into exponential equations. So take a minute, work on that, and then come back and we'll finish it up. All right, so hopefully you had a chance to work on this. So remember that the base is going to be where your log is. So it's base 2, so it's log base 2. The exponent is always what the log is going to equal to. So then that's going to be the 16. So log base 2 is 16 equals x. Same thing here. We got a base 10 now. So log base 10. So base 10s are common logs. We're going to talk about how we can rewrite those. But log at base 10 of 0.001 is going to equal -3. And then here, we're going to have a log base e, so that natural number of 70 is going to equal t. So just remember the logarithm's exponent is always what the logarithm is trying to find, so that is what's going to be equal to. If we convert these to exponentials, we got base 2, so that's 2. What it equals is the exponent, so the exponent is 5, so 2 to the 5th equals 32. Here we have a to the exponent of 8 equals q. And here we have a base t, the exponent is going to be that x, so this should equal t to the x would equal m. All right, so now we know a little bit about this conversion. We're going to take each one of these logarithms and actually find out what they're equal to. So remember what this is that this is telling me that I have a power of 10, or I have 10, and there's some sort of power of that 10 is going to equal 10,000. So since we're talking about powers of 10, this one is easy. You just go 1, 2, 3, 4. I got 4 zeros. So 10 to the 4th should give me 10,000. And like I said, you can always get a calculator out and plug these in just to make sure it's going, I think it's to the 4th, just make sure it works. But since we know 10 to the 4th is going to give me 10,000, I know log base 10 of 10,000 should equal 4. to drag that all the way through, and it didn't quite go. Okay. So here I got log base 10. So whatever the powers on, they're supposed to give me 0.01 or 1 over 100. So this kind of works the same way. Like I said, I had 4 zeros, so I did a power of 4. I have 2 zeros down here. So instead of using a positive 2, we're going to use negative 2. So kind of, it's like you're thinking about if this was 10. Sorry, if this was 1, how many times I have to move that decimal to get that number? So I have to move it to the right 4 places, then it's a positive exponent here. If I have to move it to the left, that gives me negative exponent. So one way is a positive 4 because I have to move it 4 places to turn 1 into 10,000. To turn 1 into 0.01, I have to move it to the left 2 places. So x to the negative 2 is the same as 1 over 100, 0.01. So this one is just going to be log base 10 of 0.01 is negative 2. So once again, we need a power of 2 that's going to give me 8. So I think we've seen this one quite a few times. We know that 2 to the power 3 is going to be 8. So log base 2 of 8 is just going to be 3. Here we got 9. This one power is supposed to give me 3. So just as kind of a recap on here. So if you remember, if I do square roots, that's the same as saying I have a power to 1/2. If I do an nth root, it's a power to 1 over n. Just kind of review those roots. So what we could do here is that we notice that 3, you notice that 3 is just a square root of 9. So if we're trying to figure out what power to use here, if I want to do a square root, well, I can use a power of 1/2, and that would give me 3. So 9 to the power 1/2, which is a square root, gives me 3, meaning log 9 of 3 is just 1/2. Here I need a power that I put on 6 that gives me 1. So this is one we saw earlier. The only thing power of 0 is going to give me 1. So this one is just 0. And here we have 8 to some power should equal 8, meaning that power will have to be 1. So to get back itself, the power has to be 1. My solutions page. There we go. So worksheet number 3, just once again, pause and work on these. So you have log base 3 of 27, log base 2 of 64, log base 5 of 25, log base 10 of 100,000, log base 10 of 0.0001. So the, see, thousands, 10,000ths, 1/10,000th. And then, well, what power can I put on 9 that's going to give me 0? So log base 9 is 0. Okay, so like I said, we're trying to figure out what power would do this. So for right now, if you weren't sure, like let's say we have log base 3 of 27, you weren't sure what power 3, just keep taking 3 and trying different powers until you find one that would work. So if you did this, like a power of 2 gives me 9, but a power of 3 gives me 27. Let me do a different color for that. So I see that here, if I do log base 3 of 27, well, then that would just have to be 3. Log base 2 of 64. Like I said, if you weren't sure, you can always go 2 to the power of 2. Well, that's 4. The power of 3. Well, that's 8. The power of 4. Well, that's 16. To the power of 5. That's 32. If I do to the power of 6, that gives me 64. So the power on 2 that gives me 64 is 6. So log base 2 of 64 is 6. I think this will be a little easier. What power do I put on 5 to get 25? 2. This one again, just to bring up what I had done last time. If I had 1, how many decimal places do I have to move to get 2, 3, to get 100,000? Well, we'd have to move 1, 2, 3, 4, 5. You could also just keep using 10 and putting different powers so you got this. But like I said, it's kind of a quick way. So if I wanted to convert 1 into 10,000, that means I'd have to have a power of 5. If I had 1, but I want to convert it to 0.0001, that means I have to go backwards. 1, 2, 3, 4. One, two. So I think I want 1 too many. So I was pausing there. Go 1, 2, 3, 4. No, it was just me messing that up. So if I was to move this decimal point out here, that is 4 places and moving to the left. So that is going to be the power of -4. And then F, if you filled with it, like you try to figure out, different powers of 9, what you're going to find out is that there is no, because what we had seen is that the lowest power that I could use for the most part, or not necessarily the lowest, but as you see here, that all these powers are giving me positive answers, correct? Oops, log base A. Every time, it doesn't matter what that power was, what we're getting here is that this number inside had always had to be something positive, right? So what we have here is that log base A of x equals y means this only happens as long as my x values, we had specified this before, are greater than 0. So we can't find an exponent that I could put on 10 or 9. I'm sorry. I can't find an exponent that I can put on 9 that is going to result in a 0. This cannot happen. It's essentially undefined. So that is why we get this part with our logarithms, that those x values have to stay positive, because we don't know how to do a log, how to take a exponent or take a number and put an exponent that's going to make it 0. We also don't know how to make it a negative number. It's not something we can do.